name is Ayade. Thank you for the opportunity given to our team to be part of this Cortex game simulation. Our presentation will take this format from the introduction down to the recommendation references and appendix. We have a business scenario where a non-profit charitable organization has 1 million donor members, and they need to be able to predict how many donors and which individuals to target in their next fundraising campaign. We know that in a fundraising campaign, contacting everyone or inviting everyone is not possible, hence the need for a predictive model. Also, excessive overhead spending is a challenge or one of the challenges for non-profit organization. And one of the ways to reduce this spending or expense is to boost the efficiency of donor outreach by limiting the outreach to those most likely to donate to the organization. In this project, Team Zeal came together to learn and consolidate on the learned predictive and statistical processes as newbies data analysts. Having said this, the business goal is majorly to maximize the operating surplus or the net funds raised whilst keeping expenses within a fixed or reduced budget, while the modeling objective was to then optimize and choose the best models from the suggested predictive models to predict accurately the likelihood of giving, reach out to the right donors, and finally to yield the most operating surplus. The model process flow we used in this project, the first thing we did was to identify the business problem. Then, which was what we discussed earlier, then we collected the data that was provided to us, which are the historical records of existing donor lists. We then cleaned the data, identified missing values, and converted them to either median or mean. We explored this data by going over the descriptive statistics summary of all the variables and also realized the need to transform some of these variables based on their distribution. We then splitted data into training and test sets using the 50-50 data partition. We analyzed different predictive models to see which fits well and which gave us a lower average squared error. Finally, we analyzed the result of all our models for test accuracy, comparing it with other attempts. I will further dive deep into our analytical approach. We observe the distribution statistics of all the variables to identify their distributions. We noticed some variables that were highly skewed, which we then ran a log transformation. Transformation of variables made these variables fairly normal in order to avoid problems with large values. Next is the correlation analysis, which we ran. We ran a correlation analysis using the variable clustering node to determine correlations with each other and correlations against the target variable. We observed in the variable correlation with each other that the total gift and the max gift are highly correlated at 0.956. We then decided to eliminate total gift as it had many missing values and also to avoid overfitting. Also, the correlation analysis against the target variable, which is the amount this year, showed NB activities, which is the number of participation to annual meetings, had the highest correlation at 0.047.
Thank you, Ayo. Quite a lot of sampling and modification we did there. You will agree. Hi, my name is Clara, and I'll take you through the rest of the presentation, starting with how we decided on our cutoff point. First of all, our cutoff point for this game was 90,005. We decided on this number using the scoring ranking metrics. Now, the scoring ranking metrics helped us to pinpoint the point at which the predicted value started to show decrease in the cost. The models we chose from were the decision tree, the gradient boosting, and the neural network, as well as the logistic regression. We used the decision tree, gradient boosting, and neural network, but they did not give us the solution that we wanted. or they didn't give us the optimal solution. The decision tree helped us a lot to identify indicator variables, the strongest indicator variables. The gradient boosting, when we ran it, did not give us the optimal solution, while the neural network, we ran into some time constraint problems with it, and we had to truncate it and settled for the logistics regression model using the stepwise approach. Now, why did we settle for the logistic regression model? We settled for the model because it was the easiest model to indicate significant relationship between the dependent variable, in this case amount this year, and the predictor variable. It also allowed us to compare the effects of these variables, as well as score the likelihood of donating to the campaign. It helped us to minimize the gap between errors of training data and validation data, as well as close all possible gaps between the predicted line and mean target line. In this case, we saw that the line was small, and not at this point, when the line is small, the mean predicted line and the mean line is small, is said to have an optimal solution. That's why we chose this model. Again, what were the key insights that we got from carrying out this exercise? About 88% of donors were observed not to give this year, not to have given this year, compared to the 12% that gave this year. The charts on your left-hand side, we explain clearly gave this year and NB activities, number of participation at annual events, had the largest effect on the target variable. If you see on the bar chart, it has the tallest bar. The decision tree split gave us an idea of 9 important variables that we considered out of the 21 provided for this exercise. 5 variables had over 66% of its record missing: the frequency, the mean gift, total gift, recency, and seniority. Again, from the descriptive statistic that we ran, it showed us that more donors that contributed were from the city at 83.42%, as against those from the suburb, we came second at 81.25%. Now, what recommendations and learning points can we draw out from this exercise? Based on our logistic regression analysis, our model shows variables with the highest effect being the number of participants at annual events. Now, we'll suggest that effort should be made to increase or to win more people during this annual event, as there are a large number of people participating. Based on the descriptive analysis we carried out, our model also showed that gender, in this case women, had a high effect on the amount given this year. Not just women in the city. So our focus should also be targeted, or marketing campaign should be targeted on reaching these people to make them contribute more, since the women folk have a larger appeal compared to their male counterparts. Again, since 88% of expected donors did not give this year, marketing campaigns should also be proper targeted to reach the right set of people, which brings us to the last point of focusing on the organization's return on investment, which is a good metric to measure the investments, or how investments have paid off. Now, with our regression model, we use the lift to show that this gives a better performance. Now, what were our learning points? Our learning points from carrying out this exercise are: we learned how to clean data, identify missing variables, transform variables, and determine class and interval variables. We learned how to run correlation analysis, as well as target variable correlation. We also learned how to modify parameters of a model, and also to remove complexities, eliminate complexities, make our model less overfitting, and eliminate all form of overfitting where possible, as well as make our histogram more symmetrical. Our references: appendix, which shows a list of variables, that's description of the variables, our ranking on the leaderboard as at when the game ended. We're open to questions and we'll try our best to give the possible answer. Thank you so much for the opportunity that you've given to us to be part of this game.